Hello, my name is Daniel Macias. Today for my applied calculus problem, I chose to do number 8, and the scenario reads like this. After a patient takes a medication, the concentration of the medication in the bloodstream rises at first and then falls as the body metabolizes it. Suppose the concentration in milligrams per liter after t hours is modeled by C of t equals 20t over t squared plus 4, where the interval is 0 to t12 all included. The first question of this problem is to find the derivative of c. So here I have rewritten the equation c of t. To find the derivative of c of t, we must apply the quotient rule. The quotient rule states that c prime of t is equal to the derivative of f of x, which is the top function, so d dt, because we are deriving in respect to t, of 20t, multiplied by g of x, which is the bottom function. In this case, it would be t squared plus 4, and then subtracted by the derivative of the bottom function, g of x, so d dt of t squared plus 4, multiplied by the top function, which is 20t. And then all of this is over g of x squared, so the bottom function, t squared plus 4 squared. Now, if we were to simplify this using the power rule, the derivative of 20t is just 20, then that would be multiplied by t squared plus 4, and then subtracted by, using power rule, 2t, and then the 4 turns into a 0, multiplied by 20t, all over t squared plus 4 squared. Now, if we distribute c prime of t, turns into 20t squared plus 80 minus 40t squared, all over t squared plus 4 squared. Now, if I just scroll down a little bit to get a little bit more space. Okay. Now, a little bit more simplification. If we combine these like terms, we'll get negative 20t squared plus 80 over t squared plus 4 squared. And here we have our derivative. So, the second problem is to determine when the medication concentration reaches its maximum. To find this, we need to use the derivative. So here we have the derivative, and we must set it to equal to 0 to find the critical points. Critical points. So let's set the derivative equal to 0. So that gives us 0 equals negative 20t squared plus 80 over t squared plus 4 squared. Now, if we multiply both sides by t squared plus 4 squared, it'll just cancel out the t squared plus 4, and we'll be left with 0 equals negative 20 t squared plus 80. Now we could divide this by negative 20, as both terms have negative 20 as a factor. That will leave us, sorry, we just divide by negative 20. That'll leave us with t squared minus 4. Now this is a difference of squares, so we could factor this out to get t plus 2 times t minus 2. Let's move this down a little bit. Now if we set both of these equal to 0, we'd get t equals negative 2 and t equals 2. Now remember, our interval is from 0 to 12, right? So it can't be equal to negative 2. So we must focus on just this critical point, t equals 2. Now, we don't know exactly if this is our maximum just yet. The way we check this is by splitting up this interval from 0 to 2 and 2 to 12. And now we plug in numbers within these intervals to our derivative, and then we check the sign. So our derivative was c prime of t equals negative 20 t squared plus 80 over plus 80 over t squared plus 4 squared. So now we can plug in a 1 because that's in between this interval. So c prime of 1 equals negative 20 1 squared plus 80 over 1 squared plus 4 squared. Now, the bottom is always going to be positive, so we don't have to worry about this one. We could focus on the top. Now, if we solve that out, it would equal to it would equal to 60. 60 is positive, meaning that the graph is increasing from 0 to 2. So now if we did the same thing for the interval 2 to 12, we can plug in a 3, and that would give us negative 20 times 3 squared. Let me just move this a little bit. Plus 80. Now we can completely omit the bottom part because that's always going to be positive. And this gives us negative 20 times 9 plus 80. Negative 180 plus 80 equals negative 100. Now this is negative, meaning from 2 to 12, the graph decreases now. So that means at t equals 2, we have our maximum. Now, the next question is, what is the maximum concentration? To figure this out, we get our maximum, which is t equals 2, and we plug it back into the original equation. As a reminder, the original equation was c of t equals 20t t squared plus 4. So now we plug in a 2 into t and get 20 times 2 over 2 squared plus 4. If we solve this out, we'll get 40 over 2 squared is 4 plus 4 would be 8, and this simplifies to 5, meaning that our maximum is 5 milligrams per liter. Now, D is asking, suppose the medication is considered to be in the therapeutic range when the concentration is at least 4 milligrams per liter. Find the time interval when the concentration is at least 4 milligrams per liter. To solve this, we set the original function, which is 20t over t squared plus 4, in an inequality which is greater than or equal to 4. So 20t over t squared plus 4 is greater than or equal to 4. So if we solve this out, we multiply both sides by t squared plus 4, we get 20t is greater than or equal to 4 times t squared plus 4, and then we distribute this side of the function of the equation, 20t is greater than or equal to 4t plus 4t squared, plus 16. And now we want to make this a quadratic. So we're going to move the left side to the right side to set this equal to 0. So 0 is greater than or equal to 4t squared minus 20t plus 16. Now we could divide all of this by 4 to make it a little simpler. And that would give us t squared minus 5t plus 4. Now, we have to factor this to get our interval. So our factors would be -4 and -1, t minus 4, t minus 4, and t minus 1. So our interval, where it is at least 4 milligrams per liter, would be from 1 to 4. So the next question is asking us to graph the function. So to graph, I will be using Desmos. So in Desmos, we can put in the function as c of t is equal to 20t over t squared plus 4. And now we want to set it to only the interval that we were given in the problem. So we can add some curly brackets here and just do a compound inequality here. And there we go. Now the question is also asking us to identify the maximum point. If we do C2 here, gives us 5, which is what we solved. And if we just look at the graph, perfect. Get 2, 5 right here, right at the top. Now if we plug in our range as well, where it is at least equal to 4 milligrams per liter, you can see here that we get 4 from here. See, 1, 4, 2, here, 4, 4. So that means everything from here all the way up to here would be at least equal to 4 milligrams per liter. Just another look at the graph. Now, the last problem is asking us to answer in words as if I were explaining to a biology or pre-med student. So here we have our graph. As you can see, this is our range of time from t equals 0 seconds to t equals 12 seconds. As you can see, there is a maximum here at t equals 2. From the range of t equals 0 to t equals 2, that is what is the absorption phase. Where the drug is being absorbed into the kidneys, right? Until this point right here, which is t equals 2. Now, from the range of t equals 1 to t equals 4, so 1 to 4 seconds, this is what is the therapeutic range right here, which is where the drug needs to be, the dosage of the drug needs to be. So it actually has an effect on the body and is able to treat the disease. So everything past this maximum here, this peak, is the elimination phase right here. So everything past that, as you can see, it's declining, meaning it's exiting the kidneys and it's being eliminated. So from the range of 2 to 12, the drug is being expelled from the body.